Hi all, this video is going to be on the 5 theorems that had been discovered by Thales of Miletus. This is Thales. He was said to be the first philosopher and first scientist of his time. We are going to talk about the 5 theorems that he discovered and go into little details about each one. So, the first theorem that Thales had was a circle is bisected by any diameter. We will talk about each one individually later, but first we are just going to cover each theorem. The second one is the base angles of an isosceles triangles are equal. The third theorem is the angles between two intersecting straight lines are equal. The fourth theorem was that two triangles are congruent if they have two angles and one side equal. The fifth theorem is that a triangle in a semicircle is right angle. So now we're gonna go over each one separately. Now we are going to start with the first theorem he made. It says that a circle is bisected by any diameter. So we are going to explain that right now. We have a circle right here, and then a diameter of a circle is any straight line of a segment that passes through the center of the circle. So here is the center of the circle. Here are my endpoints that lie on the circle, and I'm going to connect the lines to form the diameter. And what Thales said was that this diameter bisects. So this half is equal to this half. Our second theorem by Thales was the base angles of an isosceles triangles are equal. So first I'm going to start out by drawing an isosceles triangle, which means that two sides are equal. I'm going to draw 2 inches on each side. And then connect it at the bottom. So now we have that this side and this side are congruent, because if this side length are the same, then their base angles are going to be congruent as well. That is the second theorem. The next theorem we are going to talk about is the angles between two intersecting straight lines are equal. It's an important theorem in elementary geometry about the ratios of various line segments that are created if two intersecting lines are intersected by a pair of parallels. And that is shown by this figure. Okay, so DE, which is right here, is proportionate to BC. Then AE, right here, is proportionate to AC. And AD, right here, is proportionate to AB. The angles between two intersecting straight lines are equal, and they are proportionate to each other. Since all the sides fall into proportions, then we can say that the angles formed are equal. So we have vertical angles here, 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 and here. And they really go anywhere along the intersecting lines. So that's how they are equal. Because we know that all of the sides are proportionate in a ratio, and so that's why Thales' theorem is valid. Thales' fourth theorem was two triangles are congruent if they have two angles and one side equal. We have our first triangle right here, which I'm going to call triangle A. And then we have triangle B. So what the theorem says is that if two angles are congruent, which we have these two right here, and one side equal, therefore, these two triangles are congruent. The last and final theorem says a triangle in a semicircle is right angle. We have a circle. Okay, and then we have point A, and point B. And now I'm going to form the right angles. Now, I'm connecting point A to the line, point B to the line, and now I'm going to connect the opposites to form the right angle. So now, as you can see, we have a right angle here and a right angle here. And that's the end of these theorems. Thank you for watching.